Hi everyone, we're going to be learning about transformations. Transformations are when we take a graph and we just transform it in some way. There are three types of transformations that we will be learning: translations, reflections, and dilations. Today we're going to learn about translations, and this is when we take a graph and we just slide it to a different location on the graph. In our next lesson, we will be learning about reflections and dilations. Reflections are when we take a graph and we flip it. We can flip it upside down, we can flip it left and right. And dilations are when the graph changes size. So we are first going to start in today's lesson with learning all about translations. Think of taking your pencil and just sliding it across your desk. That is a translation. So there are four different ways that we can translate a graph, or let's say your pencil. You can take your pencil and slide it up. You can take your pencil and slide it down. You can also take your pencil and slide it left or right. Now some of you guys may be thinking, I can also take my pencil and slide it diagonally. If you're sliding it diagonally, that is actually just a combination of taking something and sliding it either to the left and up, or to the right and up, or to the left and down, or the right and down. So a diagonal transformation or translation is a combination of these four movements. We're going to first talk about vertical translations up and down. To do a vertical translation up, what we are going to do is we are going to add k on the outside of our function. So here I have something called a parabola, a U-shaped graph. And my parabola, the parent function, which we'll learn about parent functions, basically a parent function is just the basic version of your graph. My parent function is y is equal to x squared. Now if I were to take that up 2 units like this green graph shows, an example of what your equation would look like is you would have y is equal to x squared plus a 3. That plus 3 is on the outside of my x squared, and that, plus 2, because we're going up 2 units. I shouldn't have put 3. And that means that it's a vertical translation up 2 units. Now, if I were going to move my parent function of my parabola down, then that's going to be minus k on the outside of your function. So an example of that would look like this. Y is equal to x squared minus a 2. Now, when you think of translating something up, you should think of, okay, we're taking our graph and we're going to be adding something to it because we're going to be moving it up towards the positive values in my graph. So it makes sense to add 2 to your equation. Whereas when you are translating something down, you're thinking, okay, if I'm translating something down, it's going to decrease. I'm going to move it towards the negative values, so it makes sense that it's a minus 2 on the outside. So vertical translations tend to be the easier ones to remember because they make sense in terms of what's happening up or down. Now horizontal translations are the hard ones to remember. Horizontal starts with the letter H, and so does the word hard. So remember that horizontal ones are tricky. They are hard. They are difficult to remember. Now, if we have our parent function, y is equal to x squared again, and this time I am translating 2 to the left to get this green graph. Actually, it looks like I'm taking my yellow graph and I'm moving it over towards the negative values. However, a translation left, we write a plus k on the inside of our function. So it's the opposite of what would make sense. It looks like we're going towards the negative values, but we're really going to add k onto the inside of our function. So an example of a horizontal translation left would be something like this. Y is equal to an x plus 2 squared. Notice that plus 2 is on the inside of my function. It's on the inside of what's being squared. That would be a horizontal translation left. Now, something to maybe help you remember this is if we write left using a lowercase letter, the L in left is the start of a plus sign. All right, so we know that if we're doing a horizontal translation left, we need a plus sign in between my x and my number. Now, a horizontal translation right is the opposite. So if I take my yellow graph here and I'm moving it over to the right, even though it looks like I'm moving towards my positive values on the graph, remember, my horizontal translations are the hard ones to remember. We are going to be subtracting k from the inside of my function. So an example of a horizontal translation left would be y is equal to an x minus 2 squared, where that minus 2 is on the inside of my function. Okay, so these are your 4 translations. Now we're going to get started to practice. So number 1, it says to write a rule for the transformation described given the parent function y is equal to f of x. So what this means is we are going to use y is equal to f of x. Okay. And we want to translate it 7 units to the left. So when we're doing translations to the left, remember, horizontal translations are hard to remember. It's the opposite of what you would think it would be. Left is the start of a plus sign, so we're going to do a plus 7 on the inside of my function. And then we're doing 3 units down. So vertical translations are exactly what you would think it would be if we're translating down. We're subtracting 3 on the outside of my function. That is my rule. Looking at number 2, I'm going to do a vertical translation 3 units down, and that's it. So I don't do a left or right translation, so I'm just going to leave my f of x as f of x, and my minus 3 is going to be on the outside of my function because it's a vertical translation. All right, moving on to the next page. So now we are going to be using a point and actually creating the new point after each transformation. So in number 3, when we have a plus 3 on the inside of our function, that is going to be a horizontal translation to the left 3 units. When you are doing a horizontal translation, all that affects is your x value. So if I have a 6, 1 to start, a horizontal translation left would mean that I'm moving my x value to the left 3 units, which means I'm going to want to subtract 3 from that x value. So I have a 6 minus a 3, and then my y value stays the same as a 1. So a 6 minus a 3 is a 3, and my y value remains as a 1 because I did not move this up or down. So my new point after my horizontal translation left is 3, 1. Number 4, I'm going to be now, since this minus 7's on the outside, that's a vertical translation, and it's identical to what it looks like. It looks like we're doing it down, and we are doing it down. And that's going to be affecting my y value. So this is a vertical translation down. Now, we are going to be just now affecting my y value. So with the 6, 1, I'm going to take my 1, which is my y value, and I'm going to subtract 7 from it. So I wind up with 6, negative 6, as my new point on my graph after I translated that. All right, number 5. This time I'm doing 2 transformations. My first transformation is going to be a horizontal translation to the right, and my second transformation is a vertical transformation up. So let's just quick note that. This is a horizontal translation to the right and a vertical translation up. Now, remember, with horizontal translations, it just affects your x value. So for my 6, remember, horizontal translations are the hard one to remember. I'm not going to be subtracting 2 units. If I'm translating it to the right, that means I'm going towards the positive value, so I'm actually going to be adding 2 units on. And vertical translations affect your y, so my y value is 1, and I'm going to be moving it up 1, so I'm going to add 1 to it. Vertical translations are exactly how they look. A 6 plus a 2 is an 8. A 1 plus a 1 is a 2. This is my new point on my graph. I'm going to have you pause the video and try the next one on your own. Okay, so hopefully you said number 6 was a horizontal translation to the left and then a vertical translation down. And so for this one, what we're going to do is we're going to take my 6, my x value, and I'm going to subtract 1 from it because horizontal translations are the hard ones to remember. And then I'm going to take my y value and I'm going to subtract 3 from it. So my new point is 5, negative 2. All right, moving on. Number 7, I have a parent function. This parent function is a parabola. It's the y is equal to x squared. And I am going to find the graph that shows my transformation, which this transformation, it's a +2 on the inside. So what that means is that is a horizontal translation to the left. So what I did was I took my graph and I translated it 2 units to the left. So letter B is my correct answer. All right, so numbers 8 and 9 say to describe the transformation. So what we're going to do is we're going to say horizontal translation left or right by X amount of units and vertical translation up or down by X amount of units. So for number 8, since there's a -1 on the inside, that is a horizontal translation to the right 1 unit. Since there's a +2 on the outside, that's a vertical translation up 2 units. For number 9, since there's a +7 on the inside, that's a horizontal translation to the left 7 units. And since there's a +8 on the outside, that's a vertical translation up 8 units. All right, and then number 10, we are going to roughly sketch the graph after the translation. So what this means is that each one of our points are going to translate. Since there's a +4 on the inside, that means it's 4 to the left. And since there's a -2 on the outside, that means it's 2 down. So we're going to first take this point 0, 0 on my graph. And on my new graph, I'm going to translate that point 4 units to the left and 2 units down. So now it's right here. All I did was move it. Now my next point is 1, 1 on my graph. So I'm going to start at 1, 1 on my new graph. And now I'm going to move that point 4 units to the left and 2 units down. And then the next whole number point on my original graph is this point here, which is 4, 2. So I'm going to start at that point on my new graph, and I'm going to move it 4 units to the left and 2 units down, so it looks like this. And then I'll just roughly sketch my graph. This is actually a square root graph that we will be learning about in another lesson.